Hello and welcome. Today I'm going to be demonstrating how to use R Markdown files, or RMD for short. These are incredibly useful files that not only help us organize our data projects, but they also make it much easier to present our results. They can store and run code in multiple languages, R, C, Python, and so on. They can retain the output. They can generate Word, PDF, or HTML files to share results. They're powerful, versatile, and they are an invaluable addition to anyone's toolbox. So glad you're here. Sit back and let's get started. So what we have here is the RStudio IDE, which is the IDE that I typically use. And as you can see, I already have a few things open. I have an intro script, I have an RMD demo file, but I'm going to create a new RMD file. The way we do it is we just go up to File, New File, and instead of choosing R script as we would have in the past, let's choose R Markdown. Typically, something like this will come up when we're choosing an R Markdown file. So I'm just going to give it a name. You don't have to create them this way. There's lots of other ways to create them, but this is one way that I like to do it. I'm going to put in my name, and I'm going to just put 2024. Now at this point, there are a number of things that I can choose, and maybe in a subsequent video, I'll go into the different details that that you can control. But for now, I just want you to get the big idea of it. RMD files can generate, as I say, a number of different output formats: PDFs, Word, HTML, anything else. I'm going to choose Word for this one. I'm just going to choose OK. And so what we see here is we've got a file that's been given a title, R Markdown Demo, the author, and the date, and it's specified the type of output. But you'll see this file itself hasn't been saved yet. So I'm going to go ahead and do that now. Let's just do a save as, and I'll just say RMD demo. There we go. Now you may wonder what this title means, what this author means, and so on, and what I mean by the output of an RMD. If you scroll down, you'll see there's some information and so on here. But what I'll do, I will first generate some output. And in this case, it's going to generate a Word document. And this is a Word document that we should be able to hand over to someone else who can then edit it or add comments to it, or even just use it as a report all on its own. In order to do that, we go up to this spot here that says knit. And I want to knit to a Word file. So you'll notice a number of things are writing. It opens up as Word. And here's what I have here. So what you'll notice is I've got now a Word document, and I can edit this Word document just like I would anything else or any other Word document. But this is the output that's automatically been generated. So a few things to notice is the title is here. That was the title that I called the R Markdown Demo. My apologies. I'm still showing you the RMD file itself. Let me show you the Word file that was generated by that RMD file. So here's the Word file that was generated. And as you can see here at the top, we have the title of the RMD. In this case, it's the R Markdown Demo. And you'll recall that that's the name I gave it. The author, I'm calling it MathDad. The year was 2024. We've got some built-in descriptors here. These were things that were defaulted in the sample RMD. We've got a little bit of output code here, in this case summary for cars, and there's also a plot down here. So where did this all come from? and how did this get generated. But the important thing to remember is that the R Markdown file generated all of this and gave us a Word document that we can now edit and share just like we would any other Word document. Let's go back to the RMD and I'll try to put together for you how it generated this. So here we are under the RMD, and I'm just going to expand some of these things so we can see it all a little more easily. So you'll notice, here's the title. In this opening section of any RMD document, you have this, what I call a sort of a summary section here, and you'll have your title, in this case, your R Markdown demo, and it defaulted to a particular font, a particular color, a particular size. We can change those defaults if we desire, but for now, we'll just leave them at the default. Under author, we see MathDad, and that's what showed up. Under date, we've specified 2024, but we could also choose a specific date, and we could even choose it to put in a date, whatever the current date is. And in this case, the output is a Word document as opposed to a PDF, which I could do that. Now, the way an RMD file is structured is all of the white space. You can think of that as just like any other word processing. So you can just write in it like normal text. Just like a word processor or a text editor of any sort. And then you'll notice that there are sections that are dark gray or that are gray. And these are distinguished by these little start markings and end markings. And these are what are known as code chunks. And every code chunk will specify, well, a different sort of code that you're going to be using. So let me show you what I mean. To begin with, I'm going to get rid of all of these other things that are here. I'm just going to delete them. And so this is our RMD, a very basic one, very simple one, but hopefully one that will be instructive. Now, I'm going to go ahead and I'm going to knit this again so that you can see what sort of output will be generated by this RMD file. So what we see here is all I've got is an R Markdown demo, which is the title. We have MathDad, we have the date, and then we have the normal text, just like a word processing document that I've sort of typed in there. There's no R code that we've actually run. So let's go ahead back to RStudio in the RMD document and start playing around with that a little bit. So I mentioned code chunks before. So let me just go ahead and show you how you could add a code chunk. Again, very straightforward. To do it, there's a number of ways you can use it using keyboard commands, but I prefer to use this here. You'll see it says +C for code chunk. You could also do Control-Alt-L to insert it. But in this case, you can choose whether or not you want an R code chunk, SQL, Python, and many, many other choices that you have. So here we now have a code chunk, and you can see we have R in the curly brackets. It just opens and it says, this is a bit of R code that we're running here. If we generated Python, it would say that. If we generated a C code chunk, it would say that. Now in an RMD file, we do need to set things up. So I'm going to go ahead and I'm going to specify that this should be an R setup. And you'll see it automatically gives me a number of things I can choose from. In this case, I want to do an include command. And all this means is I don't want this included in my output. I want to run it, but I don't want to actually see the output. And so here I'm going to specify some of the things that I would like to have happen when I knit this file. Now I know it looks like there's a lot of typing here, and there is a little bit, but really once you have this set, I basically just use the same sort of set of code and set up at the very beginning of just about every RMD file that I run. So I'm actually going to go at this one here, and I'm just going to cut and paste everything that I've done. Typically, this is what I do whenever I'm generating a bit of R code or an RMD file. So all I'm doing here is at knitting, I'm specifying that I want any figures that I generate, any graphs, how big I want it to be. I'm specifying its width and its height because I think that that looks the most pleasing for most of the work that I want to do. And I also give a file path for where I want it to go. Now I do have a tiny little bit of code here. And you'll notice up here, there's a green triangle. And this lets me run just this code chunk. And so it doesn't really give any sort of output below it, but I have run it successfully. Now below that code chunk, I can write anything else that I want. So I'm going to include another code chunk. And in one of my other videos, I've talked about the basic setup that I do for every R code. So I'm just going to say that this next section is for basic setup. And there's a few other things that I want to say about it. This isn't the section that I want to do that in, but I'll say it will. So in this section, I'm going to clear all the plots, console, and the workspace. It also sets the format for the scientific notation for numbers. Okay, so that's what we're going to do. So let's just generate another code chunk again. If I wanted to say generate Python, you'll notice it's just an open curly Python. I don't want to do that, so let's just erase that again. And instead, we're going to include some R code. And in this case, I want to run it, but again, I don't want to see the output. So I'm just going to do include equals false. And we're going to include the same code that we've used before in our setups. So remember how I've shown you this before, or perhaps you don't. But these are the things I'm going to set up. Things that are going to clear the plots, things that are going to get everything nice and clean and ready for us to go. Now you'll notice I haven't put any sort of hashtags or anything else in front of any of this writing in the white area. And that's because these aren't comments. This is just a regular part of word processing or any sort of text editor. The other thing I'm going to do, I'm just going to specify the scientific notation and how much detail it will go to. If you don't know what these 3 bits of code here do, then please see one of my previous videos where I talk about this. I'll put a link below in the description below for that video in case you missed it and would like to review that. So let's go ahead and run this. And again, there's no particular output that runs, but we have managed to run this code so far. And you'll notice here down in the bottom, it says chunk 2. If I go up here, we'll see I'm in chunk 1, setup. And in here, I'm in chunk 2. So now let's go ahead and start playing around a little bit with this and start showing some output. So let's just include another code chunk, in this case, R. And I'm going to put in another command here called echo. Echo equals false. What that means is it won't show all of the code that I've run. All it's going to do is show my output. So let's generate a vector. In this case, we'll call it X. And we'll just, do a sequence of numbers. Maybe you'll recognize this sequence, maybe you won't. You'll notice that these are all prime numbers. So this is just the first few prime numbers. Now, if I went ahead and ran this now, again, I haven't specified any output, but you'll notice that I now have a vector X, which is numeric and 1 to 12. If I wanted to look at some output, I could do that. I could just type in X. And now what you'll notice is that it's produced output underneath it. So that's one way that you can, and that will persist. Even once I've saved this, if I open it up again, I don't have to run all the code again. I'll still have all my output there. So let's have a look. Let's just calculate the mean and the standard deviation of this data. So I'm going to, and we'll want to see what that result is. But let's just start by saying we'll round off the mean of X. We'll round it off to one decimal place. And we'll do the standard deviation as well. I'll do another video at another time to show you how to do means and standard deviations and talk about those. But for now, I'll just presume that you know what those are. If you don't know what those are, that's fine. Those are just functions. Those are just a mean and a standard deviation are just somewhat standard and fairly common calculations that we'll do. And so what you see here is I've got the mean of 13.4 and a standard deviation of 10.4. Now, of course, this isn't something, if I were using this to prepare a presentation or a report, that wouldn't be necessarily very good to just have 13.4 without any sort of context. So I'm just going to modify these slightly, and I'm going to put some commentary around them. So I'm just going to say print paste 0. And again, if you don't know quite what I'm doing here, that also is okay. Perhaps in a subsequent video, I will talk about exactly how to do this. But hopefully this code will work for you. So I'm just saying mean of X is equal to, and then I'm adding in this extra information, putting in my necessary closed brackets. And I'll do the same thing here for the standard deviation. I've got the mean of X. The advantage of generating any sort of statistical or analytical reports, doing it this way, is that as soon as new data comes in, you just need to rewrite it or rerun it. Sorry, and all of your output will remain. You don't need to cut and paste or copy anything elsewhere. Okay, so that should work just fine. So let's go ahead and see what that might look like. There we go. So you'll see what we had for our output there is the mean of X is equal to that, and the standard deviation of X is equal to, and I'm going to put in a space after the equal sign because I don't like how that looks, but we'll go ahead and make that change. Now, there's another way to do this. You'll notice I have quotations around it and the square brackets. That might look a little clunky. If I wanted to do it another way, I could even do something like cat and do, say, standard deviation of x is equal to, and then again, I'll just recalculate the standard deviation. There we go. And now you'll see that I've got standard deviation of x equals 10.4, and I don't have any of that other extraneous stuff. Well, let's go ahead and knit this to a Word document. And so we'll do that. Let's save it. And then we'll knit it. Well, again, we'll knit it to a Word document. And here you see, now I've got the output, all of that output that I generated, and it's within the code chunk. Now, again, I'm not seeing any of the code, or at least I won't be seeing any of the code in that output once it's run. And there you go. So you'll notice I'm not seeing any of the code that generated. I am seeing the mean of x is equal to 13.4, just like we did. The standard deviation is 10.4, and the standard deviation of x without any of the quotations around it. We're not seeing any of the code that I generated or used. And the reason for that, of course, is because I've specified that include, where I've specified that I don't want to. So you remember I have echo equal false because I didn't want to see that code or that output. If I put echo equal true, and by default, echo will be true, but if I did that and reknit it, then it's going to be giving me my actual output, or not my output, my code. And that's what you see here. You see it's got not just my output, but all of my code. Now, depending on what you're doing, if you're doing this and you're giving it to another data analyst or another programmer or something like that, then maybe you do want all of that code. But if you're just making a report for your manager or senior management, then maybe you don't want all of that code there. So I'm going to go ahead and I'm going to change that back to echo equals false, because I don't think they want to see all of that output. You can also generate charts and graphs and those sorts of things. So I'm going to go ahead and do that. Let's create another code chunk. And again, I'm using this shortcut. I could use the shortcut keys, or I could even just sort of type it in. So in this case, let's just do a histogram of x. And let's just do a plot of x. I'm not going to bother with giving these proper titles or axes or any of that, because I'm really just trying to show you how this works. So we're just going to do a histogram, and we're just going to do a plot. And again, these are not functions that I've shown, but perhaps we'll create a video at some point that we'll go over together and look at. So if I go ahead and run this, you'll notice that normally the output would go over here under the plot section, but instead it gives output. So here's the histogram. Again, you'll notice I've not put any axes. I've not formatted it really beautifully, but you'll see underneath here, we have the histogram. And then if we click here, we'll see that we have the actual plot of it, which in this case is really just a plot, a scatter plot over the index of what it actually is. Now, if we, again, generate the output file and knit this to a Word document, we'll just have a look and see what that looks like and how all this output gets generated. And here we see that it's generated a Word document. Again, you'll notice that it's generated history because I didn't put I didn't restrict that output. Whereas before I'd put in the echo equals false, I didn't do that with the charts. So it's actually showing me the code that we use to generate that, similar to the plot. And there's some other output. So it's pretty easy to see right away how with an RMD file, you can create a pretty slick looking report and presentation. Well, that's probably enough for now. The intention of this video, again, was just to introduce you to the idea of RMD files. Perhaps I'll generate some additional videos where we'll go into a little more detail on RMD files, how you format them, how you make them look really, really good, how you control the font size, and those sorts of things. But for now, hopefully this has been helpful. Hopefully that you've enjoyed it. If you have enjoyed it, feel free to subscribe to the channel, and feel free to subscribe to the channel, as I say, and follow along as we continue to explore not just R together, but data analysis and mathematics in general. Thanks very much. Have a terrific day, and hopefully I'll see you next time.